does
All right, let's get started here, folks. Test is scheduled for 1 week from today. Now, I looked at the syllabus. It was originally scheduled for the Monday after Easter. That's not, if grandma wants you to have another piece of cake and grandma wants another hug and grandma doesn't want you to leave yet, and because grandma's going to fill your belly more than likely, and you're going to be tired, you might not want to drive home back to campus late Sunday night. I kind of get that, right? But Friday, we are having the test. And that is where the test is. I think Friday is legit. You're still going to get out here in time. You can drive home safe. So in the syllabus, again, it was originally scheduled for Monday. It also says in the syllabus that points off for tests can be changed and the syllabus can be changed. The makeup for the test will be the following Friday after class. And if you do not take the test on Friday, a week from the day, it's going to be 25% day one off. Okay, so the test is 1 week from today. If you don't take it on that day, it's 25% off. And the makeup will be the following Friday after class. Okay. I think that's still fair. I'm more worried about you coming back. I try to make it as convenient as I can. If you don't come back on Sunday because grandma wants you to stay longer, I kind of get that. There'll be a recording for you, right? And the recording should be pretty good. So I'm willing to be flexible on Monday, but the Friday, we have a test schedule. It's just how it's scheduled now. All right, with that, let's see. Do you have quiz questions? We should be able to be 1 through 14 so far. Yes. 8. Okay. As soon as I see heat removed for number 8, I'll have these answers as negative. Maybe I should switch all these to negative. So we've got 100 grams of water at 85 degrees. We want to make ice. So here's the steps we got to take. We got to get liquid. We have to get H2O liquid from 85 degrees Celsius to 0. And that is just liquid water. We know that that is going to be Q is equal to MC, the specific heat for water, which is going to be H2O liquid, right? Probably just H2O in there. And the temperature change we know is going to be 85 degrees. Then we need to freeze. We need to do a change from H2O liquid to H2O solid. And that stays at 0 degrees. There is no temperature change. So the heat involved there is going to be Q mass times the enthalpy of, we need to fuse it together to make solid fusion. Then you need to get our H2O solid now from 0 to -5. And that is going to be Q is equal to M specific heat of ice. And then this is going to be a 5-degree temperature change. And then we have to add all this up. So there's going to be 3 things to calculate here, remember.
I guess I'm not really sure what is C for the ice.
Oh, what is specific heat of ice? It should be in our, let's see, is it in our specific heat? They can hopefully, it's either in, let's see, do we have that in here on this page? Yeah. On page, whatever page is in specific heat of ice. 2.06, this is in joules. You could do everything in joules, since this is in joules, convert to calories at the end, in kilocalories. Or you could take this value and convert it to calories. I guess my answers are in calories, so. And 4.184 joules in a calorie. Okay, what else do we have for questions on this quiz? Yes? 9. Let me see what 9 looks like. All right, we got 9. Person makes iced tea by adding ice to 1.8. Ooh, 9. We're going to add, let's see what we got here. First of all, I'm a little concerned that I want to do 1,800 grams here. We're going to add 1,800 grams of hot tea at 80. How many kilograms of ice at 0 are required to bring the mixture to 10? Okay. Well, we need to go Q lost equals Q gain on this. Now, if we're going to add this, we know that the heat lost is going to be the hot tea. The hot tea is going to get colder, right? So in this case, my hot tea is going to be Q is equal to, oh, I got it right here. This is going to be MC here, and then this is going to be T, oh, T initial minus T final here. This part right here is the hot tea. Now, over here, the ice is going to gain heat. Now, we have ice at 0. And we are looking for kilograms of ice. So we can calculate this in grams and convert it back to kilograms. Now, so the first thing you're going to have to do is melt that ice, right? It's going to melt. It has to melt if we're going to end up with a final temperature of 10. So to melt it, that is going to be the mass times the enthalpy of fusion. And this is the mass we are looking for here. Maybe I should put that highlighted or put it in red. That's what I'm looking at. Red. Now, not only is that mass going to melt, this same mass here is going to heat up, right? First of all, we are going to melt this, and that ice is now going to be at 0 degrees Celsius. Then we're going to take this same mass of ice, and we have to heat that up by 10 degrees. Because once we melt it, it's at 0, and then it has to heat up to 10 degrees Celsius. And with that, you should be able to factor an M out of there and solve that. Should work. I'm thinking that should work. But there's two things that happen to that ice, right? We got to melt it first, and then we got to get it from 0 once it's melted up to 10 degrees. Yeah, that's kind of a doozy. Anything else on those first ones? Yes.
So I have a question on mine. Is the specific heat with the mass with the 10 degrees, is that for ice or water? Since it's not
This specific heat right here is for water.
for water.
Yeah, this is for water, because you're gonna have liquid water here. Yeah, and we're not changing the temperature. The ice is already at 0, so we don't have to use specific heat of ice. Good question. What else do we have? Okay, let's look at, we are gonna be close. We're gonna be close to being kind of done today. I will send you an email when the next stuff is ready to print. The next unit stuff is ready to print. The chapter 5, all part 2 is due for Wednesday night, and the quiz is due for Wednesday night. So it should time out. Everything should time out pretty well. Okay. Here's a little summary of what we did last time. We said that if we know how much heat is coming, there's a couple of things we can do. If this reaction is reversed and we start out with water, liquid water, and break it down, we have to put in the exact amount of energy we would get out if we reverse the reaction. And that amount of energy we would put in now, this is exothermic. We would get energy out, right? But if we reverse this reaction and we made our liquid water a reactant and broke it down for these two as products, we would have to put this much energy in. It's just the exact opposite sign. So we can reverse our reactions. We have to reverse our energy. We also can multiply our reactions by numbers, and that would double our energy. We could cut this in half and our energy would be in half, and so on. That is a lot of what Al does in the beginning. Now we need to put that all together in what is called Hess's law. And this ends up being a lab. I think the next lab is CO2. Then there's specific heat. And then there is a lab on Hess's law. So Hess's law, basically, we would use this if reaction, it's the sum of reactions for reactions that are not possible to run or too dangerous. We can combine other reactions and add them up, almost like adding up equations in algebra. So for Hess's law, if a reaction is carried out in a series of steps, delta H for the reaction will be equal to the sum of the enthalpy changes for the individual steps. So here's how this works. This works really well to have a highlighter. So this is the enthalpy change that we're looking for And what Hess's law does, it combines two or more reactions to get this result that you're looking for. So here's some things we should be looking at. This, we're looking at H2O as a gas on the reactant side. And now I'm going to highlight, where's my H2O gas down below in these two reactions? And my H2O gas is a product. So I already know I need to reverse this reaction. Again, we are going to sum these up. We are going to sum these two reactions up. If we have the same reactant and product, one is a reactant, one is a product, we can eliminate it out. It's just like having 2x on both sides of the equal sign. We're going to cancel it out. So we have our H2. I already know we have to reverse this reaction to get it as a reactant. Then my other one I have, I'll use green. I have H2O liquid is a product here. And I have H2O liquid as a product right here. And there's a 2 there. So here's what we're going to do. Here's what we have to do. We are going to take this first reaction, and I think I can sneak it in right here. We are going to reverse it. Why are we going to reverse it? Again, we need H2O gas on the reactant side. So that's what we do. We're going to have 2 H2O gas. And we are going to get 2 H2 gas plus O2 gas. And then we know that this is going to become positive. And I wish we would have left enough room to sneak that in. Well, I'm going to put it right here with this arrow. This is now going to be positive 483.6. This reaction should be the same. So I'm just going to rewrite it. We have 2 H2 gas plus O2 gas. We get 2 H2O liquid. Why did I put H2O for that first one? This is just H2, not H2O. Right, this is just H2. So now, what do we have the same on both sides? We can draw our line. We're just going to add these up. But just like, again, having 2x on both sides of the equal sign, I'm going to put a light X through this as best I can. We're going to get rid of the 2 H2O or H2 gas on the product side, and we're going to get rid of these 2 H2 gases on the reactant side, right? The same. We are also going to get rid of the O2 gas on the product side here. I'm going to do a light X as best I can, and this O2 gas on the reactant side here. And now we should be able to sum this up. We have 2 H2O gas turns into 2 H2O liquid. And my heat is going to be 483.6 kilojoules and a negative 571.7 kilojoules. So delta H is equal to negative 88.1. So Al does a lot of these with two equations. And they end up being, I don't know, it kind of end up being kind of fun after you've done a few. You're just trying to figure it out, reverse it, cut it in half. It's not super powered. Some can be really ugly. But let's look at the next example here then. Well, I'm sure we're going to settle up a bigger horse on this next one. So let's see what we've got here. Take a highlighter. Let's highlight what we have here that match. So we've got phosphorus solid here as a reactant. And the only place I can see, again, we're adding these two up to get this. I've got phosphorus 4 there. And got Cl2 gas as a reactant. Oh, that's nice. We have Cl2 gas as a reactant, but look at, we need 6 here. So maybe we're gonna have to multiply this whole thing through by 6. Now, let's see what we've got here. We have PCl3 liquid. PCl3 liquid. You can see how this can get confusing because you have PCl5 solid, and we need to concentrate on PCl3 liquid. Oh, but we don't have to multiply this one by 6 at all. The first thing we need to do is we need to get PCl3 here on the product side, right? The very first thing we should be looking at. And now you see that there's Cl2 here. There's actually 10 of them. So start thinking this through. We need to multiply this one by 4, right? Because of this 4 right here. We need this 4 for sure. If we reverse this thing and multiply it by 4, you're going to have 10 Cl2s on the reactant side. You're going to have 4 Cl2s on the product side. It looks like we're going to get our 6 as well. So the first thing we are going to do is we are going to take this reaction right here, and we are going to reverse, and we're going to multiply it by 4. Reverse and multiply it by 4. So if we reverse this and multiply it by 4, I'm going to have 4 PCl5 solids and I'm going to get 4 PCl3 liquids plus 4 Cl2 gas. This is going to become 4 times a positive 123.8, right? We got to reverse the sign We changed it to a positive. Okay. Now, I think we can bring that first one down and just leave it the same, right? Let's line it up though. If we leave this the same. I don't know if I'm switching colors make it any better. I don't think so. So we have P4 solid plus 10 Cl2 gas, 4 PCl5 solid, and this is going to be minus 1774.0 kilojoules. Then my Cl2 and my Cl2. My P4 and so whatever I don't have highlighted, I messed that up. Yeah, I completely messed that up. That's not my green. I completely messed up my green. My green is right here. Should not have highlighted that. Just saying, whatever I don't have highlighted should be canceled out, but that doesn't, I screwed up. So now this is my green. I have 4PCl5 solid as a reactant, 4PCl5 solid as a product. And I should be able to cross these out. I'm going to draw my line. And I should get what we have here. We have P4 solid. Now, we have 10 chlorines on the reactant side, 4 on the product side. That leaves me 6, right? This should leave me 6 Cl2s. And then I still have my 4 PCl3s. And grab your calculators. What do we get for that? Negative 12,700, 1 decimal place here. Okay, so we still get negative 1278.8. Yeah, negative 1278.8. Okay, 1278.8.
What was that 4 times 1 to 3.8 supposed to be a negative since it says it right there?
We reversed it, so then it ends up being positive.
Okay.
Yeah, so since we reversed it, that's a good question. So reverse. Counts positive. So the reverse makes it positive. Okay. Let's look at this last one on this page here. We're gonna grab a highlighter here and see what we can get. Hopefully I don't mess up again. We've got N2 gas and N2 gas. Then we have O2 gas. We've got O2 gas here. Ooh. And we've got O2 gas here. NO2 gas. And NO2 gas. Well, then we know whatever's not highlighted is going to end up canceling out. We don't have to reverse anything, right? Nothing has to get reversed. We can't reverse anything. We've got our nitrogen gas as a reactant, which is what we want. We've got our oxygen gas as a reactant, which is what we want. We have our nitrogen dioxide gas as a product, which is what we want. But it looks like we need a 2 here. So we're going to multiply this one by 2, huh? Now, can I? We're not going to, let's do it this way. But instead of rewriting everything, I think we can do this. If I multiply everything by 2, no, let me put it up here. I'm trying to think about how you would do this. This one here looks like we haven't got a lot of work to it. So let's try it this way. So if we multiply it by 2, we're going to have a 2 here. We're going to have 2 times a half, which is really going to be 2 over 2, right? If you multiply 2 times a half, it's 2 over 2, or it's going to be 1. This is going to be a 2, and we just put a times 2 here, can we? And this one right here would stay the same, wouldn't it? So I think we'll just draw a line and do it. So we are going to end up, well, let's see, can we eliminate? Yes. Let's do our cross out. We've got 2 NO gas on the product side here. We got 2 NO gas on the reactant side here. We'll get rid of them. I think we got it. So we have N2 gas plus an O2 there and an O2 there. We get our 2 O2, right? This is 1 O2 and this is 1 O2. So we've got 2 O2 gas. And we get our 2 NO2 gas. So we didn't reverse anything. These signs are going to stay the same. We're going to multiply that by 2. We're going to get a positive number. We're going to get a positive 60 something. 66.4. No. No. 114. 114. Well, yeah, this is 114.12, but we still have to subtract that from the 180.
Okay. I got 66.4.
66.4 kilojoules. next page. This is example 5.9 of the textbook on page 207. Whoa, we're definitely the highlighter here. We definitely the highlighter here. We got carbon solid here, carbon solid here. We've got hydrogen gas here, and we've got hydrogen gas here. Whoa, there's a lot of oxygen. Whoa, they all got to be eliminated. CH4 gas. Yeah, that's it. So it looks like we can reverse this. And you're kind of thinking this through. You're looking at what we have to eliminate. All of these have got to go, right? We have to get rid of our O2. There's no O2 in this. So as we do this, we're going to have some O2 on the other side anyway. It looks like there's a 2 here. So I think we're going to get there. Because when we multiply this one by 2, we're going to get 2 over 2. We're going to get an O2 here, plus the O2 there is 2 O2. If we reverse this reaction, this 2 O2 goes on the other side. So let's do what we have to do for sure, no matter what, and that is to reverse this one. So let's put this down. We're going to reverse this. We're not going to multiply and reverse at the same time at this point. We're just going to reverse. And by the way, there's way different ways to do these. So this, don't think there's only one way to do it. Okay, so we're going to reverse this. So if we reverse this, we got to eliminate CO2 as well in that water. So we're going to reverse it. We're going to CO2 gas plus 2 H2O liquid. And we're going to have CH4 gas plus 2O2 gas. And delta H is, we're just reversing this. So this is going to be plus 890.3, right? Now I think we're going to be, we got a 2 right here. There's no 2 here. Let's bring number 2 down. We're just going to multiply it by 2. So if we multiply this by 2, I'm just going to put a 2 in front. All right, so we're going to have 2 H2 gas plus 2 times 1/2 O2 gas. And we are going to get 2 H2O liquid. So delta H is going to be 2 times negative 285.8 kilojoules. And I'm hoping that this one can be the same. And by the way, you can add up these two and start from there. So there's numerous ways to do it. You could add up the reaction at the end, flip it, whatever it takes. Lots and lots of ways to do this. In this case, we have carbon solid plus O2 gas. And we get CO2 gas. And delta H, that stayed the same, so we have negative 393.5 kilojoules. Let's see. Here's my carbon. Here is my 2 hydrogens, and then I need a CH4, where's CH4 here? That means everything else has to go. That is, I guess if I have that much highlighted, I don't know. But let's cross out what we have here. You've got a CO2 and a CO2. So we're going to eliminate this CO2 here with this CO2 here. 2 waters and 2 waters. I'll change colors as I cross these out. I'm like, no, 2 waters and 2 waters. And now all these oxygens are going to go. There's 2 oxygens here, there's 1 here, and this is 1 oxygen, right? So we've got, we're going to eliminate this, these are all gone. And we've got, we have 2 hydrogen gas. Oops. And my final delta H is going to be negative 74.8 kilojoules. I should put this one on the quiz instead of here. I thought this one was on the quiz. First time I did this problem, the 1/2 was missing. And after about an hour, it's like, what? Something's not right here. This one can be done so many different ways. Let's highlight this. Let's see, we've got CLF gas. We are not going to get this one done. CLF gas, is it anywhere else? I think so. Let's do F2. F2 is there. Is it anywhere else? And then CLF3 here. The rest of it needs to go. Okay, it looks like we need to reverse this. right? We need to reverse this. This is 2 CLFs. We need to keep this the same. I'm just going to draw these because I want to be cognizant, and we'll come back up and do some. We're going to cut this one in half. So I guess I'll go times a half or divide by 2. And in number 1, what do we got to do? Number 1, what do we have to do for the first one here? We got to reverse it and cut in half, right? So we got to do reverse times 1/2. So I will write this out here. So if we're just going to reverse this, we've got 1/2 Cl2O plus 3/2 OF2. I'm sorry, I should have put, this has got to be a gas. This is a gas. Are they all gases? Yeah, that would make it cleaner. They're all gases. Everything's a gas. I don't have to worry about, okay, so I'm gonna, everything's a gas, then that's fine. Then we are going to get ClF3 plus O2. Everything's a gas, so I'm going to quit cluttering it up. Negative 266.7. Did I get, oh, did I just, oh man, look at what I just did. I just made a mess. Because I started looking at the wrong one and I didn't follow the right arrows, so I did that. No, I was all right. No, I wasn't. I did all right. So we're going to have 1/2 of, we can reverse that, so negative 49.4 kilojoules. And the very last one, we're going to go reverse times 1/2. No, did I just? Yeah, I did mess up, didn't I?
Yeah.
I did mess up completely. I reversed it. I reversed it and 1 times 1/2 the wrong one. Might be a good time to stop. You can finish that one. On the quiz, you should be able to do, there's a lot of Hess's law in, there's a lot of Hess's law in ALF, a lot of them, and they're just 2. I think they'll go really, really fast. You should be able to do 16 and 17 on the quiz, 16 and 17. So 1 through 14, 16 and 17, and we'll finish this up on Monday. Answer any final questions Wednesday, test on Friday.